So this will be our first video of the polynomials unit to review, and I was going to start off with degrees and terms. So let's do terms first. A term is the grouping of numbers and letters separated by pluses or minuses. So in other words, it can be a number, which we call the coefficients, or constant terms, combined with a variable, which we call the letter, combined with a letter, and then the fancy name gets called variables. So letter, which we call the variables. So let me give you an example. For x is a term, x, y, z is a term, 5 is a term, 16 over 9, xp is a term. So the reason that I said the numbers can be coefficients or constant term comes from this differentiation between these two. Let's say, for example, 4 is a number that is glued or multiplied by a variable, so that's called a coefficient. It doesn't change when you change, it does change. This answer will change whenever I input a number in for x, because then I'm going to do 4 times that x, and say if it was 2, we get 4 times 2, so this would become 8 at the end of it. But 5 is a constant term because no matter what I do for x, it'll always just be 5. So constant terms have no variables. If you were to do an example now to count number of terms, it's pretty easy to see them. Let's say we were doing x squared y minus 11x plus 2y squared minus 6. You count the number of terms by everything that's separated by a plus and a minus. So here's my minus, plus, minus. So that means this is a term, this is a term, this is a term, and this is a term. This one would have 4 terms. Now if I move on to degrees, the degree of a term is different than the degree of a polynomial. So first you need to understand the degree of a term before we go to the degree of a polynomial. The degree of a term, let's go back to this 4xy example, is the sum of, sum means add, all exponents. Just as a quick review, for example, exponents are made up of, or they come from powers. So x to the power of b, this whole guy together is the power. So the whole entire thing. B is the exponent, and x is the base. I know, there's lots of new words, guys. So back to this example, finding the term degree for this term, I need to add up all of the exponents. So for this power right here, there's actually a secret exponent 1 in there. Every variable has a secret exponent 1. So then when we label that, we can easily see the degree of the term is 1 plus 1, so therefore 2. When it comes to the degree for polynomials, though, you do the exact same you do the exact same thing. All you need to do is find the degree of all of the terms, but the degree of a polynomial will always only be the highest polynomial. It will always be the degree of the highest term only. So don't add up the degrees of all the terms. That's not right. They're equal. The degree of the polynomial is the same as the degree of the highest term. So for this example over here, I'm going to go in and write all of my secret exponent 1s.